A simple event is one event or situation. A compound event is a combination of at least two or more simple events. To find the probability of a compound event, you multiply the probability of these simple events. Never, ever, 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 ever add. So we're just looking at these to decide if it's simple or compound. We're not solving, we're just labeling. Number 1 says a committee has 8 female and 12 male members. What is the probability of choosing a female? How many different things are we choosing? Just a female. Are we choosing once or twice? One time. That is a simple event. Number 2 says a bag has 3 green, 2 red, 5 purple, 10 white, and 5 black marbles. What is the probability of choosing a black marble? How many marbles are we choosing? 1. 1 makes it a simple event. Number 3 says a bag has 3 green, 2 red, 5 purple, 10 white, and 5 black marbles. What is the probability of choosing a black marble, replacing it, and then choosing a purple marble? How many marbles are we choosing? 2. Which one of these is 2? And number 4 says, what is the probability of rolling a number cube, getting a 5, and then flipping a coin and getting tails? We want a 5 and tails. That's 2 events. So that is compound. Okay. Independent and dependent. Independent means one doesn't change the other. Dependent means one changes the other. So, if you roll a number cube and toss a coin, does one change the other? Does it matter what I get on my number cube? Nope, that is independent. Number 6 says taking a marble out of a bag and then taking a second marble out of the bag. This is the key right here. Without replacement. If I have 10 marbles in a bag and I take one out, how many marbles are left in the bag? 9. Did I change what was in the bag? Yes, that is dependent. Number 7, choosing a person from a group of 50 and then choosing another person from the same group. If I take somebody out of the group, does that change who's in the group? Of course it does. That's dependent. Drawing a card from a deck of cards, putting it back, and then drawing another card from the same deck. If I put the card back, does it change how many cards are in the deck? No, that is independent. So it says, for the following problems, use the image as reference to help you solve the problems. So we have this weird image over here. It says you randomly choose an object without putting them back in. This is important. What is the probability that the first object is a fork and the second is a heart? So you have 2 things going on. You have to label it like this. You have a heart and you have a fork. What is the probability you get a heart? One heart out of how many objects? 1, 2, 3, 4, 5, 6, 7. Now, you do not put the heart in, so it's gone. You've pulled it out. This, oops, I did it backwards. Sorry, my goodness. First is a fork. Second is a heart. What is the probability of getting a fork? That is 1 out of 7. Now we take the fork out. What's the probability of getting a heart? 1 out of 1, 2, 3, 4, 5, 6. Now this is what you're going to do. You're going to multiply 1 times 1, 7 times 6. Ta-da! Not too bad. Number 10 says you randomly choose an object and replace it. What is the probability that none of the objects is a heart? And that none of the objects is a heart and a second is a heart? Okay, so first object, not a heart. So not. Second time, we want a heart. So not a heart the first time. 1, 2, 3, 4, 5, 6 out of 7. Now we replace it, so we put it all back, no matter what we drew. And now we want a heart. So that's 1 out of 7. Do you see how this time the bottom number didn't change? Because we put it back, right? So 6 times 1, 7 times 7. $11 says you randomly choose 3 objects. Again. What is the probability you get a heart, a tree, and an umbrella? So we have 3 things. We have a heart, a tree, and an umbrella. First, we're going to draw a heart. 1 out of 7. Now it says we don't put it back in, so the heart disappears. Next time we want a tree. 1 out of 1, 2, 3, 4, 5, 6. Don't put it back in. Now we want an umbrella. That is 1 out of 1, 2, 3, 4, 5. 1 times 1 is 1, times 1 is 1. 7 times 6 is 42, times 5. I think it's 2. Double check me. Then it says, what is the probability you get a heart, a tree, and an umbrella if you do put the objects back in? So heart is 1 out of 7. Tree, we put the heart back in, right? Now we want a tree. There's 7 total objects. And then we want an umbrella. That's also 1 out of 7. So let's see. 7 times 7 is 49. Times 7. Mm, 34 maybe? Something like that. 343. 1 times 1 times 1. All right, 13 says probability of getting red. 14 says probability of selecting a club. Here's your clubs. There are 13 clubs. So probability of a club, 13 is your top number, and 52 is your total. All right. It says use the picture for the questions 15 through 17. What is the probability of selecting a red card, not replacing it, and then selecting a spade? So the first thing we want is red. How many red cards do I have? 3 out of 5. And then I want a spade. Now, spades are the ones that look like upside down hearts. How many spades do I have? I took a red out, but I still have 2 spades out of how many? 4, remember, because I did not replace it. Top times top, bottom times bottom. You will need to divide by 2. What is the probability of choosing a black card, putting it back, and then choosing a heart? So black card and a heart. We have 2 out of 5 black cards and 2 out of 5 hearts. Remember, we put it back. What is the probability of selecting a diamond, not replacing it, and then choosing red? So I'm going to take a diamond out. That's 1 out of 5. And I am not replacing it. Now, how many reds are there? 2 out of 4. You got it. The spinner below is spun twice. That's 2 times. What is the probability of an arrow landing on a white space and then a space with stars? So we want white and we want stars. How many whites are there? 1, 2, 3, 4. Out of how many total? 8. And how many stars are there? 3 out of 8. Matt has a bag containing 6 $1 bills and 8 $5 bills. Without looking, he pulls one bill out and places it on the table. If he puts it on the table, he's not putting it back in. Then, without replacing it, he picks a second bill from the bag. Which ratio shows below shows the probability he will select 2 $5 bills? So you want to know the first time, what's the probability he'll select a $5 bill? 8 out of 14. He does not put it back. So now you have 7 out of 13. Chloe has a bag of coins. The bag contains 8 dimes, 3 nickels, 2 pennies. She will randomly select 2 coins from the bag, one at a time, without replacement. What is the probability Chloe will select a nickel and then a dime? So I want a nickel and then a dime. Well, my nickel is 3 nickels out of 13 total. Without replacement means this changes. I take a nickel out. Now I have 2 nickels. So when I go to draw a dime, that's 8 dimes out of how many total? 12. You got it. Kylie has these bags of chips in her kitchen cabinet. She will randomly select 1 bag of chips without replacing it and randomly choose another bag of chips. What is the probability she will choose a bag of Ruffles and then Cheetos? So you need probability of Ruffles and Cheetos. So 3 Ruffles out of 6 total. Now she doesn't replace it, so we take the Ruffles out. Now we need Cheetos. How many Cheetos are there? 1 out of how many? 5. And then you're going to multiply top times top, bottom times bottom. A bag contains 4 sour apple candies and 3 watermelon candies. 1 piece of candy is chosen at random and returned to the bag. Probably important. A second piece of candy is chosen at random. What is the probability both pieces will be sour apple? I want sour apple. What's the probability I get sour apple the first time? 4 out of 7. Do I put it back in the bag? Yep. So what's the probability I get sour apple the second time? 4 out of 7. Multiply and simplify. Okay, 29 says there are 8 girls. The girls are represented numbers 1 through 8. If each girl needs a dance partner, which list shows all the possible combinations of the girls at the dance class? So we have 8 girls. 1, 2, 3, 4, 5, 6. We're going to make a sample space, a list. Who can one partner with? Well, one can't partner with themselves, but one could. 4, 5, 6, 7, or 8, right? Now, who could 2 partner with? 2 could partner with 1, but if you look, 2 and 1 are already been partnered. So I don't need to list that again. 2 can't partner with itself, but 2 could partner with 3, or 4, or 5, or 6, or 7, or 8, right? So who could 3 partner with? 3 has already partnered with 1 and with 2. So 3 could partner with 4, 5, 6, 7, or 8. Does this make sense? Because when 4 goes to partner up, 4 has partnered with 1, with 2, and with 3 already. So 4 can partner with 5 or 6 or 7 or 8. Because we're not going to list the same partnership twice.